Hello, Assalamu alaikum. God bless you all. Today we are going to do theorem 12.1.2, second theorem of chapter number 12, class 9. Okay, I have made many changes in it to make it smooth, to make it fluent, so that it will be easy for you to learn. Okay, and easy for you to understand as well as learn and then score good marks. Okay, keep this in mind. From this chapter, one theorem will definitely come. So exercise them, practice them, and you will get it out easily. Okay. Now, if you read the statement, I have used word statement or enunciation. First of all, let me explain you these two words. Statement, you are familiar with. Enunciation, I've used word. You can see the dictionary also. Enunciation means what? Sorry. Enunciation means, suppose if I proclaim or claim that this is my mobile, okay, then what you will do? You will say this is my mobile. Then we will go to somebody, maybe judge or any third person, and tell him different or give him different statements. Then we will give them the reasons. Okay, this is my mobile because I have my pictures in it. Okay, you will also say my pictures are also there. Okay, so this is statement and reason. Enunciation means to claim something. Okay, in Urdu it is called dawayam. You can see from the dictionary also. Okay, enunciation is better word for statement. I have written both. Okay, now read the statement. Prove that any point equidistant from the end points of a line segment is on the right bisector of it. You can read from the book also. Okay, now I can explain you this statement from the figure. That is much better. Okay, now so we have a what? AB line segment, and we have a point. What is the relationship? We have a point P and a line segment AB. In such a way, the relationship between these two is such that PA distance is equal to PB distance. That is why I have made it very smooth statement. Look at this given. There is a point P, clear, and a line segment AB such that PA distance is equal to PB distance, congruent to PB distance. PA distance congruent to PB distance. We want to prove that point P lies on the right bisector of AB. Now I will explain this proof statement after construction. That will be easy. Okay, now construction. For construction, what we have done? We have taken midpoint of AB. We have taken C as a midpoint of AB. Again, I have made straight, smooth, fluent line so that you can learn. We have taken C as a midpoint of AB and join C with P. Look at the construction. Take C as a midpoint of AB and join P to C. Look, join P to C. Easy? Okay, now I was telling you that I will explain you what does this mean. Okay, now it means we want to prove that P lies on the right bisector of AB. So when we have joined C and P or P to C, it means this line, if it is a perpendicular bisector of AB, it will have two characteristics. You can say properties. Okay, what will be those? You know, right bisector has two characteristics. One is it divides the line segment into two equal parts. That we have already done in construction. That AC and BC are congruent because C was the midpoint. So if this is 5 centimeter, this will also be 5. This we have done in construction. C. Take C as a midpoint of AB. Done? Okay, then next. Another thing we have to prove that this ACP angle or BCP angle, both are or each of them is of 90 degrees or both of them are 90 degrees. So that it should be perpendicular as well as bisecting AB into two equal parts. Keep this in mind, perpendicular can be here also. But if it is here, this AC distance will not be equal to BC distance. That is why it is written perpendicular bisector, not only perpendicular. So when perpendicular bisector is written, it means this line will divide this AB into two equal parts as well as make 90 degree angle with AB. Done? Okay, now we will go to proof. Okay, now for proof, it is written statements, reasons. I have written little congested, so please don't mind it because of the less space. Okay, whatever the availability of the space is, I try to use it. I write this before so that you know if I write in fluency, my handwriting is also already not so good. Okay, so if I write this directly uh, while explaining you, then I will not be able to manage the space. So please don't mind it. Okay, now next, proof, statement and reason. What is this? In triangle ACP corresponding, this sign I have already explained in 12.1. This sign is correspondence. So triangle ACB has a correspondence with triangle BCB. So triangle, in triangle ACP corresponding triangle BCP. First I will read this for you, then I will go there and explain these. Okay, now look at triangle ACP. ACP, done. And triangle BCP, easy. Okay, which two triangles? ACP and BCP. Okay, now next is PA congruent to PB. Where is PA by? PA congruent to PB, and this was given. Look, PA equals to PB given. So this is what? PA congruent to PB given. Now next line is PC congruent to PC common. Look, PC is present in this triangle also, and PC is present in this triangle also. Done. Then next, AC congruent to BC. Why AC congruent to BC? Well, AC congruent to BC. What is the reason? Reason is construction, where C is the midpoint of AB. So that is why. Got it? Okay, next. Next is, now when three sides of one triangle become equal to or congruent to three sides of any other triangle, then both triangles become congruent. That is why we have written triangle ACP congruent to triangle BCP. Three sides of one triangle ACP are congruent to three sides of another triangle BCP. Got it? So this is called SSS postulate. Now when triangles are congruent, then each and everything of there will be same in size, same in shape. So we can say that angle ACP has become congruent to angle BCP. Look at this, angle ACP and angle BCP both will be equal to each other. When they both are equal to each other, now next, I have changed a little from the book now. Please concentrate. You can show this to your teacher to check its authenticity. Okay, he will appreciate you. Now, so we have done what? Now I have added these two, ACP plus BCP. Look, ACP was there, BCP was there. Now I have added them. Whenever I have added these two adjacent angles, and they make what? Like when you stand and do like this, you make what? Two adjacent angles. Okay, 90 each. So total becomes 180. So this has become ACP plus BCP 180 degrees. This is called supplementary angles. If the sum of two adjacent angles is 180, then they are called supplementary angles. So that is why I have written ACP plus BCP is equal to 180 degrees supplementary angles. Got it? Next. Now, measurement angle ACP plus measurement angle BCP. Here ACP, ACP. Here BCP, again ACP. What is this? Okay, now see, look. Here BCP was equal to what? ACP. Done, already proved here. BCP is equal to ACP. So I have replaced that BCP again with ACP. Look, instead of BCP I have written ACP again. Okay, one it is same. This is replaced by ACP. This is already there. Now this one ACP plus another ACP will make it two measurement ACP. You agree? Addition of angles equals to 180. Now I have divided this side by 2, this side also by 2. Dividing, I use symbolic because there is no space. So dividing both sides by 2. So symbolically I have written dividing. Now, so when you divide it, okay, it becomes 90. Now we have got angle ACP equals to 90. Calculated from the numbers, figures, everything. Okay, very neatly, nicely proved. Okay, so ACP is equal to 90. Now here ACP was equal to what? BCP. So if ACP equals to 90, then it was equals to BCP, that will also be 90. You got this idea or not? Okay, got it? Okay, now. So now when this is 90, so PC, ACP and BCP are of 90 each. This one is of 90, this one is of 90. So then PC will become perpendicular to AB. PC will become perpendicular to AB. Look, PC perpendicular to AB. Reason, okay, look, reason from one, because ACP both angle, ACP and BCP both angle are okay from 190 degrees. Done. They now next is AC is equal to BC. That C was the midpoint in the beginning we have taken in the construction. That is why AC equals to BC, okay, as C is the midpoint. Okay, now I told you that right bisectors will have two characteristics, two properties, two things necessary to be a right bisector of any line segment. So line segment was AB, and if PC is the right bisector, it should be perpendicular. We have proved it. It should divide this AB into two parts. We have proved it. Okay, that is why now I have written PC is the right bisector of AB. Why? Because already proved that it is perpendicular and it bisects the AB into two parts. So I have written from 2 and 3. Look, this is 2, this is 3, and this will come here. You got it? Next. So this is, if this is a right bisector, then C is lying already on AB. So what is the other point? P. It means P is also lying on right bisector. So this was the need. Look, to prove the point P is on the right bisector of AB. So point P is lying on the right bisector of AB. Thank you so much. If you have any difficulty, any confusion, you can write in comments. If you want to understand something, you can say from physics, chemistry, maths, biology, English. Okay, you can write down in comments, and I'll try to teach you that also. Okay, I'll get a side so that you can take it screenshot and then you can learn it. Again, I'm telling you, this is very smooth. Okay, very fluent. Please put lots of concentration, do lots of practice. Thank you so much. God bless you.